Hello everyone, I'm recording this video a little late because I realized I was doing it wrong before. Yeah. Anyway, I'm gonna jump right in, and we're looking at 3 problems, examples that I just came up with off the top of my head. And we got some important notes over here, just kind of law of inverses and the domain of sine, cosine, tangent, which is important when dealing with inverses. So first of all, we'll just look at this first problem here, and you'll see cotangent of the arc cosine of 4/7. So the biggest tip is to just make this inverse our tangent. So that just equals the cotangent of theta. Now the cotangent of theta just equals adjacent over opposite. A cool trick or thing to think about here is that we're dealing with cosine, which deals with adjacent over hypotenuse. So realize that theta equals arc cosine 4/7. Then cosine of theta equals 4/7. Simple. Move it all the way across. Well, that equals our adjacent over hypotenuse. And we Pythagorean theorem this bad boy. We've got a squared plus 4 squared equals 7 squared plus 16 equals 49. A equals the square root of 33. So we found all 3 sides. We still don't know what theta is, but that's the cool part, because we don't need to know what theta is. We need to know what this equation equals. And we're looking at adjacent over opposite. Well, we've just found our opposite side. So this problem equals 4 over the square root of 33. Or if you want to rationalize, you end up with 4 square root 33 over 33. Boom, 1 down, 2 to go. Similar setup equation here with the inverse on the inside. And I'm going to go ahead and just apply the same principle. Super easy. We skip a step here and we see secant of theta equals 9 over -5. Some people are inclined to switch to cosine for, peace of mind, I guess. But either way, you'll end up with hypotenuse over adjacent, or adjacent over hypotenuse. We do a little bit of Pythagorean theorem here, and then we'll end up with, we got opposite squared plus -5 squared equals 9 squared. So our opposite side equals the square root of 81 minus 25, which is 56. And now that we have our opposite side, realize sine is opposite over adjacent. And you'll get square root of 56 over -5. See, you'll see in this situation, our origin would be point A, where our opposite side is -56, and our adjacent side, or opposite side, is square root of 56, excuse me, and our adjacent side is -5. Down here, we look at this seemingly simple equation where we have the arctangent of the tangent of 7 pi over 4. Well, 7 pi over 4, the tangent of 7 pi over 4, say, following our law of inverses, equals 7 pi over 4. Well, what does 7 pi over 4 equal as well? We refer back to our trusty old unit circle. We got sine over cosine here, negative square root of 2 over 2 divided by square root of 2 over 2. We get -1. Well, that's going to be in our range, and our range for tangent can be negative infinity to infinity, so that our domain of tangent, if you look, is negative pi over 2 to pi over 2, and in that indication, it's just within this range. So we have our tangent in this range. And you notice that our sine is also in the same domain, or our inverse sine is still in the same range. Something to help you remember is that our odd functions, the sine and tangent functions, operate on the right hemisphere, and our even functions operate on the top hemisphere. Zero to pi, as you see. So does this answer even actually work? Because we're looking at the arctangent. Does that operate within the range, or I should say the domain of the arctangent? The answer is yes, it checks out, because 7 pi over 4, the tangent of 7 pi over, tangent of 7 pi over 4 is the same as the tangent of negative pi over 4. And negative pi over 4 is within our range. Negative pi over 2, pi over 4, negative, and pi over 2. I hope that these help you out. This helps me out a lot, and good luck on the test.